My name is Shane Murphy. I'm Sales Director at Ashgrove. I'll give you a quick introduction in a second, but as you can see there at the bottom of your screen, you have a little Q&A section. One of my colleagues is keeping an eye on that during the webinar, so anybody who wants to ask a question, just throw it in there and we'll cover it. I'll cover it as I'm going, if the questions are appropriate to the part of the presentation I'm in. If not, I'll cover it at the end. So we'll start away. 2 seconds. So we'll be covering kind of the basics of solar. I won't be going into the big heavy technicalities of it or exactly how a solar panel works, etc. But we'll be just covering the basics. We'll be talking about the cost of solar panels and the payback in Ireland. I suppose we have this perception that you know, we don't get a lot of solar in Ireland. The science will tell us all in a second. We'll be talking about the grants for solar and the criteria for meeting the grants. Not that there are a lot of criteria in solar, being honest. We'll be talking about your house. When I say your house, I mean any specific house and how we design it. And then we talk a little bit about inverters, battery types and sizes, and why you would use a battery or why you maybe would not want to use a battery, etc. We'll talk very briefly about how we would attach to the roof of a house, the various fixing mechanisms, etc. And at the end, if I have questions that we haven't covered, we'll go through Q&A. But I'll try and cover them as I'm going if you throw in your questions there. So, tiny bit about Ashgrove. I won't bore you with this. Ashgrove are around since 2001. We have been specialising in heat pumps and solar since then. We've been working with SAI since 2006, so that's the Sustainable Energy Authority of Ireland. So those are the guys looking after the grant administration. And then we've about 15,000 systems in operation around Ireland and the UK. Now, they're 15,000 different types of systems. They could be anything. They could be heat pumps. They could be solar panels, etc. From small up to very large. So we'll be talking about domestic only today, though. So we do about well, it'll be more this year. 2021, we had about 1,000 projects where we designed them, we installed them. Obviously, the quality, the QA has to be perfect for where we're dealing with SAI. It has to be good anyway, because we don't want, when you're doing that amount of projects, everything is just checklists and sign-offs. Then we'll have certification, we have handover to the customer, and then of course you're kind of starting your post-install relationship with your customer, which is kind of 20, 25, 30 years, whatever it is. So kind of service and maintenance arrangement. Lastly, as I said, if you have any questions, throw them up on the little Q&A box there, and either I'll cover it or my colleague will reply to you if appropriate. So SAI, who are they? You know, they're the Sustainable Energy Authority of Ireland. Their mission is to assist us through incentives or regulation. Today we'll be talking mainly about incentives, but it's to do with the transition to a low carbon future over the next 3 years. Today we'll be talking about the housing stock, and we know that there's about 500,000 houses to be upgraded between now and 2030, which is a massive ask, and we all suspect that it won't be hit, but I suppose, you know, the whole industry is ramping to do as well as we can on that. So solar panels, what types do we have? So what we're going to be covering today is solar photovoltaic. How it works, I'll be explaining a tiny bit of the science in 2 seconds, but it produces, essentially coming off the roof, you have direct current, DC current is produced by the panel, and we convert that over to alternating current, which is what we get out of our plugs or our sockets rather. What do we use it for? We can use it to heat hot water. We can use it to run your appliances, so your heat pump, your TV, your washing machine. You can charge batteries with it. So you can have a solar battery, you can have a car battery. And if you have all of those things done, you can export any surplus out onto your electricity grid. We'll be talking a little bit about that. There's also solar thermal. So these are solar panels that produce hot water. So this is where the water passes through the panel on the roof, and it ends up getting hot. So we can use this to heat hot water. We would often also use this for swimming pools. This is something we don't see much for domestic houses anymore. There's good reasons for it. It's nothing wrong with it as a technology, but it's limited. And certainly now when we can sell excess electricity onto the grid, even when you're overproducing, you can get a return. If you're overproducing with solar thermal, it's all going to waste. And then you have a thing called solar thermodynamics. So this is some of you might have come across it. It's where you have a black panel on the roof, and inside it, instead of water, you have a refrigerant, and it will take heat from the air or the sunlight. Again, it's used to produce hot water or pool heating. This is, we would very rarely use the bottom two here unless it was something like a commercial swimming pool or something like that. So today we're only going to be covering that top one. So how does a solar panel work? I'm not going to go into the big detail here, other than I'll explain that photons of, let's call it light particles, are hitting that panel, and I'll shortcut all the science bit and tell you that out of the wire here at the end comes direct current. And we can either store that in a battery, or we can put it through an inverter, which converts it over to alternating current, AC current, and then it becomes useful for us. Not going to go into it any more than that, and I'll jump onto a kind of a domestic house. So what does it look like for somebody like you or any normal house? So you still have your panels on the roof. You might, in this case, they're both facing, let's call it south, and you've DC current arriving. No battery in this case into your inverter, gets converted to AC current, and at that point that AC current goes straight up here into your fuse box, your fuse board, and that now can go to your fridge, your cooker, your TV, your air conditioning, your lights, etc., your heat pump, your charger, your electric vehicle. Now, if at that point it's all done, you can then charge up your battery if you had one, and once that battery is full, you can decide, okay, at that point I can do no more with it. I've stored as much as I can, and I can export the surplus to the grid. We'll be talking a little bit about that in a second, and how you can do it and how you sign up for it, and what you can expect in terms of cost per kilowatt hour from your electricity supplier. So we won't be covering these, but just some of you, we're coming across people who are asking a lot about bifacial panels. It's a buzzword in the industry. So of course, the sales guys take every opportunity to sound fancier than the next guy. But a bifacial panel is no surprise, I suppose. There's two faces on it. And it would be for typically a solar panel standing in a field like you'd see in a solar farm. So you have obviously the energy that's hitting this, the solar panel from the front. That energy gets absorbed. But for any energy that misses the panel and hits the ground behind it, that gets redirected. So there is light behind it. It's not that it's totally dark behind the panel. There is what we call diffuse radiation. So that's light that doesn't come directly from the sun. It bounces around through clouds or whatever else, but it makes its way to the back of the panel. Of course, if you can imagine that when that panel is sitting on your roof, this does not happen. So if any of you are coming across that, a bifacial panel, yes, we have them. Do we use them for domestic roofs? No, we do not. Okay, but that's what it is anyway. It increases the efficiency of your solar panel by 10 to 15% in terms of annual output. Of course, there's a jump in cost as well, an equivalent jump in cost. So yeah, we don't use them on roofs. So that's that boxed up. So when we go through a little bit of science here. So when we look at any house, we have people say, I have a roof, it's facing south, it's facing southeast, southwest, whatever it is. I'd like to put up 6 kilowatts of solar, or 4 kilowatts, or 5 kilowatts, or my brother put up 4 and I should put up 4. Well, why do we say that? Well, what we would typically do is we would get a person's electricity bill for the last year, maybe the last 2 years, and try and get an idea of their 12-month profile. So as an example, at my house, I have a heat pump, I have an EV charger, I have, maybe electricity usage that my neighbor doesn't have. So therefore, my electricity bills are going to be higher than his if I don't have solar, because I'm using more electricity than he is. So, because I have a heat pump, obviously January, February, my usage is going to be higher than it will in May, June, July. And then as I come towards winter again, my heat pump will jump up, as would lighting, would maybe tumble dryer might be busier in winter than it would be in summer, and so on. So we get a 12-month profile. I'll show you one of them in a second. So when we get a person's electricity bills, that's what we're looking at, because from one house to the next, we don't know. So that's the 12-month profile. The second thing we're looking at is the 24-hour profile. So the first one here that you see is what we call a double peak profile. This might be something like my house. I get up in the morning, a small jump of energy usage in the morning, kettle, toaster, whatever it is, right? Maybe hot water production, the heat pump might ramp up a little bit, whatever, 5 or 6 o'clock. And then during the day while I'm at work, really, there's not much happening. There's nobody there, there's no TVs, no lights, very little happening. So, and then when I get home in the evening, of course, cookers, lights at the moment, TV, Wi-Fi, we just say tumble dryer or something like that, if you can imagine. So that's what we call a double peak profile. And by comparison, then a single peak profile, if you can imagine, say, retired couple, they don't have the early spike in the morning. And so they have a kind of in general, a load through the day that tapers off in the evening. So what does this mean? For us as solar designers, if we look at the double peak profile there, you can see I've drawn in by hand this solar profile. So you can imagine Shane leaves the house, and after he does, the solar starts to produce. So in this case, everything below the yellow line and above the blue line is surplus. So I end up having to export all of that because I can't use it. And if you can imagine, I don't have a battery, so I can't store it. So I have to export all of that electricity. So what this tells me is that in a double peak profile, in Shane's scenario, he's going to be exporting a lot of electricity, and he's going to get paid whatever it is, 12 cent, 15 cent, 18 cent, depending who you're dealing with. So, so I'm going to get paid for it. But when I buy it later on here in the PM 7 or 8 o'clock, if I want to buy it back in, I'm going to be paying 30 or 35 for it. So I don't want to give it away for 15 and have to pay 30 for it later on. So there's a strong argument here for Shane having a battery. Whereas in this single peak profile, there's a strong argument for not having a battery, because they're going to consume the energy as quickly as it's being produced, and therefore you would have the additional cost maybe of a battery, but with potentially no additional advantage. Okay, so we're looking at two profiles. We're looking at your annual profile from January to December. That gives us an idea of your annual consumption. And then over a 24-hour period, we're looking at a slightly different profile. We're looking at your lifestyle. So I'll jump into the software in 2 seconds and we'll discuss more on that. But before I go into it, I just wanted to give you, presumably what most of you are here for, an idea of cost. So I just said I'd pop these in here. So a 4 kilowatt system at the moment for us is kind of 8,800. This includes VAT, and there's no grants subtracted. So that's the top one there, 4 kilowatts with no battery. So that might suit, say for argument's sake, my parents. The bottom one might suit somebody like Shane, who's gone to work at 7 o'clock. So 8,000 for 4 kilowatts, 4 kilowatts of battery, 12 to 12.9, 6 kilowatts is 10.5 to 10.8, and 6 kilowatt with a 5 kilowatt hour battery is 14.3 to 14.7. Now, of course, there are caveats there. I'm assuming that it's a relatively straightforward roof. I'm assuming that we can get at the roof. There are, believe it or not, there are projects when you get out there, the house is surrounded by rockeries or ponds or something, and you literally can't get on the roof without having some sort of a fancy cherry picker or something like that. That obviously has to be taken into account, but infrequent, I'd have to say. So, and then to give you an idea of grants, so this is after reducing from last year. They'll give you 900 per kilowatt for the first two. So if you put up a 2 kilowatt system, they give you €1,800. For the next 2 kilowatts, they'll give you 300 per kilowatt for the next two. So if you had 4 kilowatts, they'll give you 1,800 for the first two, and they'll give you 600 for the second two. So that's a total of 2,400. And no matter what you do after that, you're not getting any further grants for a domestic scenario. So maximum 2,400. At the moment, these to be eligible for the grant, the house has to be built before 2021. The BER is not important, unlike some of the other grants. It's irrelevant whether you're a G or an A. So I'm going to move on now. So if you have any questions on this as I'm going, guys, please fire it in there to the Q&A. So this is maybe a carry or a follow on from what I was saying a while ago. We get information on your house. So what we take from that is we need your air code. And we also ask for MPRN numbers, and we need bills and so on. But when we ask for your air code, what we essentially do is we can provide it Google Earth images allow. We get a picture of your house from a satellite, and you can see here we can very quickly make a 3D image out of that. So you can see this house here on the right. I'm going to use it as a case study, even though it's actually a live project. So this house is, we know a lot about it. We installed a heat pump about 15 years ago. And you can see here, when we put in the location, it tells the software, number one, where on the planet the house is. So in this case, we'll just say it's Limerick. The next thing, from Google Earth, it also pulls with it the orientation of the house. So we can see this house is facing almost perfectly due south. Right, and what the software tells me here immediately by looking at this image is this bright yellow is the sunniest part of the house. The north-facing roof is dark, so that's telling me there isn't much what we call solar irradiance, the amount of kilowatt hours that hit each square meter per annum. So that's coming from 30-year statistical data. So that comes from the Met Office and down into the software. So this is where we should have the solar if we were not constrained. As it turns out, there's actually Velux windows here, so we're looking for the next best option. This was an east-west system on the front of the house, with the chimney maybe wasn't a great idea. So this customer has opted in this case to put the solar on the garage. Now that's an east-west system, and what's interesting about that is it would be intuitive to a lot of us that east-west might be significantly worse than south, and the science here will tell us otherwise in 2 seconds. So he has a cable in this case between the garage and the house. So any energy that we produce on the garage will be reverse fed back into his fuse board. Okay, so you can see here that the electricity bills that we receive. So we have January, February, right through to December, and you get this profile that I was describing a while ago, where in January, February, March, you can see the energy consumption is dropping, and again towards the end of the year it's increasing. We would be, you know, that's self-evident that would be the case. Clearly, as I said, tumble dryers. In this case, there's a heat pump. There's 2 electric vehicles. So now that wouldn't be weather dependent. To be fair, normally we'd be driving the same amount in summer or winter. So. But what is less evident is, and I'm sure you guys are probably hearing it all the time, you can see here in January that the solar isn't doing a lot. February is building, March is building, April, and so on. And so we get the peak output there in June and July. So, and again, that's coming from statistical data. I hear, and sorry, the solar team here, he would hear this quite regularly, that some guy told me that the solar panels didn't need direct sunlight anymore. They just needed daylight. And that's clearly not true. We'd all like it to be true, as much as we'd like to convince ourselves that there's as much solar energy in January as there is in June or July. It's simply not true. So don't fall for it. So you can see there that we get this bell curve, so a distribution of energy increasing towards summer and decreasing towards winter. So we would have a lot of customers who'd say to us, I have a heat pump, and I would like to offset its consumption. Obviously, your heat pump is going to be consuming a lot in December or in January, February, and my solar is at its worst in that case. So I can't offset it right there and then. My best bet is to try and offset it in June or July and to get income to, I suppose, just to balance out the costs that I had in winter. But anybody telling you that, as you'll see here in a second, we can give you a system that will produce 5,000 kilowatt hours a year. At the same time, I can show you that your heat pump is consuming 5,000 kilowatt hours a year. Quite often, the homeowner will put those two pieces of information together and say, I'm consuming it for my heat pump 5,000, or say the heat pump is sick with 5,000 kilowatt hours, and my solar is producing 5. Sure, they'll balance each other out, sure, but they won't, because one of them is in winter, one of them is in summer. So as much as we'd like to, that won't work. Well, up to a point. So I'm going to click into this. So I'm going to go into the proposal or the design of this system. I won't kill you with details, but so you can see there that this is east-west facing. By the time I pull this into the software, it's going to rotate 90 degrees and I'm going to be looking down at the top of it. And then we can remove or include panels as we see fit. So I'm going to click out of that 2 seconds, guys. I'm going to click on this and hope that it does it. Connor, you might confirm for me that it's up on the screen. No. Yeah, it is now. Good. So what you can see here, guys, it's after rotating the garage now. It's a particularly poor image out of Google Earth, I'd have to say. Now this is going back probably a year and a half, so the prices are a little bit outdated, but we can go with them anyway for the moment. But you can see here that this particular couple have opted, well, what they've asked us for is an option for 23 panels with a small battery, 23 panels with a slightly larger battery, 18 panels, etc. And you can see here that I can flick through the options. So we can see here as an example, the net system cost is 10,000 without the battery. If I add a 5 kilowatt hour battery, it adds the cost, right? And if I go to 18 panels, you can see everything jumping around here. Now, so we'll scroll way down through it. So this customer can look at this and decide what they want to do. We can give them as many permutations as they want. So we can see, as I said, to start off with, we know what the system demand is for the year. We have 10 years of electricity consumption data, and this gives us this gray line, this profile I was telling you about a while ago. And if I go for 18 kilowatts of panels, sorry, 18 panels, not 18 kilowatts, you can see here that everything is calculated for me. So I'm getting 33% of my energy from solar, 82% of that is being consumed on site, and 18% is being exported. Whereas if I jump to 23 panels and no battery, all of those figures change. And if I go to 23 panels with 5.1 kilowatt hours of battery, again, they change again. So I'm going to continue on down to what would happen in the, you can see here, by the way, this would be on any general proposal that we send out, guys. So you can flick here. I'm accessing this the same as a customer would. I'm not even inside in the actual design software. This is a standard quote that we send out. So in the case where this customer is generating excess solar, the house is consuming some of it, the battery is consuming some of it, and there's some of it being exported to the grid. Now, the reason that some of it is being exported to the grid might mean that the battery can't absorb it quickly enough. There's only a certain rate at which we can put that into the battery, and therefore anything above that would be going to the grid. Now, that should be very little, but it does happen the odd time. If we have a scenario where the solar is only partly covering the load for the house, so we'll just say on a day where the house is consuming, I'm going to say 10 kilowatts and the solar is producing 5, well, it takes whatever it can from the battery, and you might get help from the grid as well. Again, that might be because we can't get it out of the battery quickly enough. There are scenarios, and I'll explain that in a second. There are scenarios where we can't get it out of the battery quick enough. And then lastly, if you were in night and obviously your solar is producing nothing at night, you're either consuming from the battery or you're consuming from the grid. So what else does this report give you? It gives you your savings. It'll tell you, we can put in here your energy costs. So you would give us those. You could tell us that you're paying 30 cents and that, you know, if it's whoever, I'll discuss it maybe in a second, depending who it is, SSE or Electricity or anybody else, Pinergy, we can put in the costs that are relevant to you, and then it produces this financial report. So in this case, for this particular customer, it gives a 20-year prediction here. Now we know that the solar panels will last 30 or more because they're guaranteed for 25, and they're actually guaranteed to be producing at the end of year 25, they're guaranteed to be producing at least 87% of what they were year one. So for anybody who thinks that just because this is saying 20 years here, that, you know, in year 21 they'll explode or fall off the roof, clearly isn't the case. They're guaranteeing them at 87% at the end of year 25. So either way, they've taken a 20-year view of it here from a savings point of view, which is reasonable, to be fair. So they're saying that my savings over the 20 years are going to be essentially 41,000, and my cost is going to be 12,900. That's after the grant, I should say. Right? Sorry, it's not. Apologies. I'm going to just check. Yeah, that's after the grant. So it was 15,900, so 16,000 before the grant minus the grant brings me down. And then, so over 20 years, he's going to save 27, nearly 28,000 over 20 years. So I'll just maybe come back up here. So he's saving roughly 1,700 per year. So that's a good saving, right? Again, if I take out the battery, you can see here that the savings drop by whatever that is, 120 or 30 euro. But of course, keep in mind that the cost of my system has changed as well. So what's interesting about this is because of this guy's usage profile, 2 electric cars, it's a very large house, by the way, as you can see there, 23 panels is, I should have said that at the start, is an exceptionally large domestic system. So you can see that if my net savings will go from 27,800. If I take out the battery, my savings actually go up. Now, it's not that I am saving less with the battery, it's just that my original outlay was higher, and my savings from the battery didn't cancel out the initial cost. So that's quite counterintuitive, I'd have to say. It's driven into all of us that a battery is a good thing. And in this case, you can see here that the reason for that, by the way, he's using the energy as quickly as it's being produced, and therefore the battery never really comes in to play. Now, so what else is inside here? That's essentially T's and C's and so on. So that's did I have anything else to say to you inside there? Yeah, so it's 9 kilowatts, as I say. That's a large system. So typically, as domestic, probably doesn't go above 6. So I'll shoot back out to the presentation. I think Connor is answering away the questions there as we go, guys. So, so now that gives us all of the numbers we just saw there are from an east-west system. The other thing about an east-west system is if we had east-west might suit also say somebody like Shane here, who's gone in the morning, might be there for a while in the morning, so could benefit from the solar gain in the morning and again in the evening. If we had something like a business that had, like we saw in the previous profile here, so you had a business, and as the sun was shining, you know, from 9 until 6, the business is open or whatever. So there's a strong argument for them to not have a battery, right? And quite often that would be the case. Now, emotion takes over in a lot of cases, and people say, "I want a battery, Shane," and that's fine. All we can do is advise them, and they can do whatever they want. But we provide them with the science, and they can decide whatever they want after that. But anything else to say on that? Yeah. So okay. I'll keep going. So the feed-in tariffs. So the feed-in tariff is essentially if you're feeding electricity to the grid, It's referred to as a feed-in tariff. You will get paid for each kilowatt hour that you sell. And you can see here, I've taken this, and we've taken this from this website. There are various websites, SAI or whatever, but anyway, it's not fictitious. We haven't made it up. But these are, you can see here that Energia will give you more than SSE. That said, if you're buying your electricity off Energia, they're also more expensive, when you're buying from them. So you'll have to balance that up, or we'll assist you by putting it into the software there. So that's where we got it from. So you're getting anywhere from whatever 14 cents to 20 cents. So yeah, and that'll be metered on your smart meter, and you'll be credited that every 2 months according to your on your bill. The reason that you only get whatever 14 or 18 or 20 cent there, and when they're selling it to you, they're charging 30 cent. Well, obviously, as more and more people have their own solar panels around the country, or wind turbines, the grid is selling less and less electricity. They're selling less product, yet they have all the same infrastructure. They have all the maintenance. And of course, the day that my solar panel isn't working, I'm still going to demand from EirGrid that they back me up and give me electricity. And of course, that service has to be paid for, as opposed to, so you're in the future review, maybe that they're going to be charging you for the service and maybe not for the kilowatt hour. So that's reflected in the cost. The overhead is probably different, and a bit of profit. So if we do decide for your house, or you decide for your house that you want a 5.1 kilowatt hour battery, so that's kind of a standard normal battery for a house, we're asked quite often, well, how long will that last, right? So we just put together just a little chart there to give you an indication where, certain things are tiny. So as an example, second from bottom there, an LED light is 3 watts, whereas an electric shower is 8,000 or 9,000 watts. So, and to do the maths on that, if I run, I'm going to go with, what will I go with here? A blow heater. And the blow heater is about 2,200 watts. If I run that for 1 hour, that will be 2.2 kilowatt hours. So, and I have only 5.1. So I could run that blow heater for 2.3 hours before emptying the battery. Whereas if I had a 7-minute electric shower, and yes, I'm using a lot of power while I'm doing it, but I'm only inside it for 7 minutes. So that draws just under 1 kilowatt hour. So that will empty 20% roughly of my battery of energy. So I can take 5.5 showers here. Now I'm going to be in the dark at that point, so maybe we wouldn't decide to do that. So your heat pump is 2,000 watts, and that would run for, that typically runs for hours. Whereas maybe, say I put in I thought there was a blow dryer in there as well. So, but a blow dryer would be minutes. So, but that puts it in context, guys. Your phone charger is 7 watts. Your LED light is 3 watts. So you could run that for 1,700 hours, however many days that is. That's a month or whatever it is, without emptying the battery. Your freezer can run for 102 hours. Your fridge can run for 23 hours. Sorry, I skipped the television. So 65-inch television can run for 40 hours. Your dishwasher can run for 3.5 hours, 3.8 hours. Your kettle, it's only on for 5 minutes. It uses a lot of power while it's on, but it's only on for 5 minutes. So, you could boil the kettle 12 times. So anyway, what does this tell us? The battery, provided we treat it with a little bit of care, can, I could certainly have my television on, my lights on, I could boil the kettle, I could keep the fridge and the freezer running, I could still charge my phone, and it would do me overnight if I was careful. But the minute I start turning on tumble dryers, I mean, in the event that there was a power outage, you'd be certainly turning off the tumble dryer, maybe the blow heater, the electric shower, potentially even the heat pump ultimately. But that gives you an idea of what the various items consume. So what size are solar panels? We're getting in a small bit to the workings of it now. So they're typically about 1.7, 1.8, maybe 1.6 high. So that's 5'6" to 6 foot-ish, and they're about a meter, so 3.5 feet wide. You know, you've probably all seen them at this stage, no surprise. Your typical inverter there on the right, that's about 1.5 feet wide by 2 feet high, and it's, I'm guessing, just under 7 or 8 inches in depth. So that's kind of the size we're dealing with. So here's something I tried to rustle together, a photo with all the relevant bits in one spot, even though it's a particularly terrible photo. But so this is what we would have in a normal attic. Now, sometimes this would be in the garage. It might, in some cases, have to go into the utility room. And if it was in a utility room, obviously these things would be stacked in a neater arrangement. But so I'll start here with the inverter. So the electricity comes down from the roof. The first thing it goes into is this thing called a fireman's switch. And this is basically, if you can imagine that the house is on fire, there's a guy going to come in any second. He's going to start spraying water all over the place, thinking that when he has turned off the power outside, that it's safe to start spraying water. And of course, you have solar panels potentially producing electricity on the roof, and the guy is dead. The other thing is, so that can't be allowed to happen. So if somebody turns off the power outside, it also kills the solar. Secondly, the other reason for that is if you had a scenario, which can happen, where people are producing electricity and the power goes out on the grid, that you could be backfeeding electricity back out onto the grid, and there's a guy outside trying to fix a cable, and all of a sudden he's getting 230 volts from your house. It's not a great scenario either, obviously. So there are various safety mechanisms there that we all have to adhere to. So, but that first one is the fireman's safety switch. That has to be within 1.5 meters of entering your attic space or penetrating your roof, essentially as close as possible, for it to be as safe as possible. That electricity then, once it comes off there, it'll go ideally, in this case, it's going to a battery, straight to the battery, and then it reverse feeds back out of that, out into your inverter and off to your house as alternating current. You can see here you have various isolators. You have an AC isolator, you have a DC isolator, AC isolator, and you have a battery isolator. So that'll give you an idea. If you have an attic, what space it'll take, or if it's in a garage, it'll be whatever. If you don't have either of those, these will somehow, some parts of it that'll have to be in the attic. And this would have to be accommodated maybe somewhere in a utility room or wherever you can fit them. But you know, that's it. So here are two other ones. So that's a 6 kilowatt hybrid inverter. So this would be a 6 kilowatt inverter. In this case, it's a SOFAR inverter. So that again is about the bones of 2 feet wide, slightly less high, and then the various gubbins that go with it, various isolators, and so on. And here's a 3 kilowatt string. So a string inverter is what we refer to, it's how we refer to an inverter that is not compatible with a battery. So a lot of people would say they don't want the battery now. They maybe don't have the budget for it, and in that case they might put in the inverter. But if they were considering putting in the battery down the road, they might now put in the hybrid inverter, which would allow them to put in the battery. But being honest, they're a relatively cheap piece of kit. So that hybrid inverter there is probably, I'm going to say, €500. So maybe not that cheap, depending on the way you're looking at it. But as a part of the overall package, it's not a massive component. Now, it's a necessary component, obviously. But if it was a case that in 4 years' time you were intending on putting in the battery, but you weren't sure whether you were going to do it or not, you might be as well off to just put in the string inverter. It's cheaper than the hybrid, and you know, maybe flog on the inverter to some guy on eBay or Done Deal or whatever it is, and try and get a few £100 for it. So that's it. But the hybrid, some people are just putting in the hybrid and putting in the battery in 2 years. That's yeah. Again, we give them as much science as we can, and after that, it's their decision. So how do we fit solar panels? So you can see here I've shown maybe different types of roofing scenarios. So I'll take the slate there being front and center. So you can see here you have this little bracket like I have on the bottom right of the screen here. So they'll take out a few slates. By the way, with slate, we're almost guaranteed to break 1 or 2 of them or 10 of them. So when we go out to a house with slate, we find out what type of slate it is and we take a bundle of them with us. As you know, no matter how careful you are, it's inevitable. And so we pop out the few slates. We then maybe just cut a slot like this, and then you're sealing it. You're putting another slate down over it, and as you see here on the top right, then you get this little plastic fitting that goes down over it, which gets sealed once it's in. So what we're trying to do there, obviously, is get a good strong fixing onto your rafter. But of course, we can't have a scenario where there's any potential for water to get back up there and down into your house. So we have obviously all the insurances for that. So once that's done, this is what you're looking at. You're looking at this bit of a bracket, and that little elongated hole there is what then ties up with this bracket that you're looking at here. So these are anodized aluminium little, what would you call them, frames. And as you can see then, the solar panel gets snapped onto that and bolted down. So, you know, it's an extremely secure mechanism. And it's, you know, anodized aluminium is corrosion proof and all the rest of it. So even for something like kind of sea locations, we'd say, where you might be getting salt water blowing in storms and so on. So just another thing on that, when we see it here on the roof, there's no good picture. We'll take this one here. From the bottom of the roof, from the gutter to the bottom of the panel, we have to be 500 millimeters away from it. I'll come back to the other roofing types in a second. You have to be 500 millimeters up from the bottom. You have to be 300 millimeters down from the top, and 300 millimeters as well from either side. Now that's an SEAI guideline. That's not a building regulation, but if you want to get the grants, that's what you have to adhere to. Now the reason for that is that what they're trying to reduce is the possibility of strong winds getting under the panel, and you know, on the west coast of Ireland, or you know, northwest, you know, we experience winds that they typically don't elsewhere in Europe. So you know, keeping it away from that edge reduces the possibility that the air will get under it and so on. So yeah, it is overkill, we know that, but it's better to be safe than sorry. So I'm going to go back to this fella. So that's the slate done, let's say, and then we go on to some sort of a tile. So this is a more modern, I'm guessing it's a cementitious tile, but we would essentially pop these out, and when you have them popped out, you can put in the same bracket again, up, connect it onto your rafter, and put back in your tile again on top of it. The ultimate aim, of course, is still the same. We want to get this aluminium rail connected to the frame again, and yeah, and snap the solar onto that. There is a third option, which is this last fella here. If for any reason we can't get those tiles or slate out, we will drill a hole through it. But as you can see, this is a little stainless or an aluminium tile, and it slides up under the other tiles, up about 300 millimeters, 400 millimeters, up as far as it can. And the fixing that goes down through it is going down through the hole. But as you can see, as the water runs off the tile above it, or even if it goes in between those two tiles, it's down onto the aluminium or the stainless tile. It comes down, and it'll run away either side of that little bolt, and you know, there's no way that the water would start to backlog up the 10 millimeters that it would have to before it hits this little rubber grommet. So like the chances of water getting in through that these days is the chances are zero. 10 years ago or 20 years ago, that was a much more rudimentary mechanism. You know, we're trying our best with silicone and stuff like that, but you know, they're really bulletproof today. So that's kind of the fixing mechanism. Again, to get you then obviously have to get cables in. The cable is a similar type mechanism to this, and and so on. So now you can see here in this case, it's the original picture was better, but there's a chimney. That chimney at some point in the day is going to cause shading on the adjacent panels. And in a case like that, if I have wired, let's say 5 panels together and one of them is experiencing shading and it's pulled down, I'm just going to say it's pulled down its efficiency to 20%. Well, because the other 4 are connected to it, they all get pulled down, right? So in a case like that, if we know what's going to happen, we'll see that on the solar design, and we will advise that we put in these things called either optimizers or mini inverters. And the mini inverters, well, I won't go into how they work, but I'll just say that if you're experiencing shading on one of the panels, it doesn't affect the other 4. As well as that, if one of the panels got broken, now they're a hard enough thing to break, being honest with you, but you know, contrary to what we would all understand, we might think these are glass. Some of them are glass, but most of them today are a form of plastic. You can actually walk on them. And again, we're not advising that, but you can. And so the chances of breaking them are slim. But if for any reasons, you know, something did break and one of the panels is down, or 1/3 of one of the panels is down, but all of a sudden it pulls down the output of the other 4 with it, if that's the way they're connected. So that's why we might use something like optimizers. Again, because of the chimney, the optimizers or the mini inverters. So depending on the scenario, we might choose a different system design. So I'm nearly at the end of this, guys. So if you have questions, fire them in. By the way, obviously we could be here for the day discussing the infinite detail on types of inverters, or which battery is a Huawei better than a whatever so far. You know, that's for another discussion. Today is kind of an introduction. Or if you're talking about a farm and you want to put up 50 kilowatt or 17 kilowatt under the mini generation, or if you want to go up to something bigger, that's for a different day. If you want to fire an email at us and just in the subject title put in for the attention of the solar division, it'll make its way to the relevant persons. And so I just wanted to make the point here. This was a project that we did last year, and where in general, actually I didn't really speak about the solar grants other than the amounts. It's known as a Better Energy Homes grant. It's what's known as an individual measure. So you can go off and get your grant. We'll help you in doing that. It's quite a simple process, surprisingly, compared to what it was a few years ago. And but I'd just like to take the opportunity to say that these houses that we're looking at here are houses that we did about just over a year ago, where these people contacted us about solar panels, and we went through all of the stuff we just discussed there, their bills, their usage profiles, etc. And we discovered that their solar panels were going to be about 7,000. But when we, at the same time, we looked at their house, and we could see that there was a kind of a sister grant called the BEC, or a one-stop shop, but we'll call it, yeah, either of them is fine. But under that grant, these houses fell into a sweet spot where if they insulated their attic, insulated their walls, and got a heat pump, I'll show you here. So the semi-detached houses, year of construction 2003. The houses were 103 square meters, 2-story. Before the house was, or before we did anything, they were a C2. The works undertaken. We eventually did an attic and wall upgrade, an air-to-water heat pump. I think there were 5 kilowatt, and solar panels. The grant covered, and this is the idea of the one-stop shop, which you're all hearing about, which hasn't really been that successful, not because it's not good, but because it isn't suitable to a lot of projects, and very few companies really are geared to deal with it properly. But in this case, you can see that it really worked. The cost of that work was 8,100, where the solar panel itself would have been 7,000. Now, the reason for that is, the criteria are different. You have to get to a B2 now, right? Which these houses did. We have to be doing energy and insulation upgrades, which these houses did. We also had to prove that the house was poor to start with and really good to finish with. And evidence of that is measured in kilowatt hours improvement per square meter. So you have to improve the house by 100 kilowatt hours per square meter per annum. You don't need to remember that other than the gist of it. But we were able to improve these houses enough to get into the scheme. And the minute you do, you get the solar grant, you get the attic grant, which more or less covered the cost of the attic. The walls, in this case, probably close enough to covering it. But you also now get these bonus payments. You get a bonus €2,000 for the heat pump. The heat pump grant is 6,500. You get 2,000 to upgrade your radiators. And all of a sudden you can see there that it all adds up to a really good deal. I'm not saying it's suitable for everybody, but it's anybody who rings looking for solar or a heat pump or something like that, we flag it to them. Not that we're trying to discourage solar or heat pumps, obviously, but it might be in isolation the wrong move for you. And the last thing I'd like to say is, so there's the post-works BDR. So, and we take that house went from a C2 to an A3. Of course, the minute you get past the B3, you're now into the green mortgage situation where your mortgage can drop anything from 0.3% to 0.9, I think is the biggest reduction we've seen. So we would have people contacting us regularly just to get solar panels or to maybe do attic insulation or whatever, just to get to the B3 so they can get the green mortgage. I don't have anything to add. There are questions coming in there. Now, the last thing I'd say is every month we do a face-to-face seminar. It's about 2.5 hours. It's not solely about solar, even though we do cover solar in it. It's mainly to do with home energy upgrades. The next one is this Saturday coming. And you can either contact us or maybe hop onto our website for upcoming events, and you can log on and register there. But they're free, no different from this. We're not going to be chasing any of you guys following this call. We're nearly too busy as it is. But we're trying to do these information events where possible to maybe, I suppose, educate as many people as possible in one go. I don't mean to insult anybody when I say that, hopefully. But, you can imagine at the moment, our business is getting a lot of inquiries, and sometimes it's impossible to get around to all of them in a reasonable amount of time, despite how quickly we're trying to ramp up and hire people. So that's it. If you have any questions, Connor is typing away there, helping. And what is your current timeline from order to install? It's typically, depending what if it's just solar, it's 6 or 8 weeks. If it's solar and say somebody wants windows or doors, which we also do as part of a one-stop shop or a BEC, that'll be after Christmas at this stage. Windows being the lead time there. We're not tied to any window company. We're typically using whoever you guys want, or we point you to a handful of companies that we kind of deal with regularly. But we don't have any preference. In most cases, the homeowner, believe it or not, organizes it and gets all the prices and so on, and we just organize the grants, and we might organize the logistics of getting it installed and the scheduling of that. But hope that's answered. Next one. Okay, I've that already answered. Okay, guys, I'm done. Please send. Actually, I should have asked at the start of this. Maybe we'd love to know where you heard about this webinar. We spend a lot of money, I suppose, on advertising. We're trying to figure out what works and what doesn't work. But any help would be appreciated. Okay, enjoy your day. Best of luck. Take care. Bye.